Hey, my name is Dave Marisek, and today's presentation is the Nakusp and Slocan Railway circa 1906. The design, build, and operate. So this is why I'm doing the build series and gives you a bit of a insight into things. This was a presentation I gave to the Railway Modelers Meet of British Columbia this year, so it'll help you understand why I'm doing what I'm doing. The pictures throughout are also the views I want to build. So this was Nakusp in early days, the station, the wharf, and the barge slip. Um, so what we're going to cover, the NNS right-of-way, where was this railway, my design criteria and constraints, how I built the layout. The operate video already exists as build 4 of the series. This picture here for Carpenter Creek is great. A big chunk of the railway ran along Carpenter Creek, and it will show, that's the vision I want to create of a railway hanging to the edge of a creek, running down with the cliffside right to the rails. So this is what a lot of it will look like in a few years. So why build? In 1906, I moved from Victoria, which is an outdoor G-scale, the picture here for the Low and Fur Railway in Victoria, which is also well documented on my website, to Vernon, which I'm doing indoor. I have a passion for proto-ops with a few engineers playing roles. I like short lines, and this has 2 stern wheeler and rail barges, so great. Grew up in the Kootenays. I have a 1906 timetable, lots of money invested. Everything was reusable. I had approval for space in the basement, and I needed an engineering challenge in retirement. So why not build in G-scales indoors? History. So silver was discovered in 1891 in the Slocan Range. The first 36.5 miles were built in October 1894, and later 4 miles to Sandon in 1895. Why? Well, the Caslo and Slocan Railway, a Great Northern Railway, built to Sandon in 1895, and back then, if the Great Northern built it, the CPR would build it. But more importantly, the Arrow Lakes had a section called the Narrows, which were shallow or frozen. So all of the freight traffic from the CPR main line to the Kootenays and Boundary up until 1916 had to get through by using the NNS. So they would barge to Nakusp. The NNS would take the cars to Rosebery. They would rail barge on Slocan Lake. Columbian Kootenay Railway train would pick it up and take it to Nelson, and a Columbian Western train would take it to the Kootenays and Boundary. So this was critical for the development of the entire area, all the way from Midway to Nelson. Where is it located? Well, halfway between Calgary and Vancouver, south of Revelstoke and north of the U.S. border. This is what we'll be building. As you can see, the Upper Arrow Lakes is a major part at Nakusp. Summit Lake is a big portion along the railway, and Slocan Lake is from Hills to Rosebery. So those 3 lakes are prominent. And then the profile, 2.5% up to Summit, 2.5% down to Rosebery, 3.5% up to Three Forks, and 4.5% up to Sand. And so tough mountain railway here, not much level. The picture there is Elmo. Elmo was a concentrator, and again, it gives a good feel for Carpenter Creek and how narrow the valley was. The entire railway was built around the stern wheeler schedules. So in Nakusp, you had a northbound arriving at 12:25 from Robson. It would be picking up empties or any loads coming out of the Boundary region going to Arrowhead and up to Revelstoke. Southbound, you had the Revelstoke Arrowhead train, stern wheeler 13:45, with all the general merchandise loads coming from Boundary into Cusp. And then on Slocan Lake, you had 2 stern wheelers a day, one at 9:30 and one at 4 o'clock into Rosebery. So you'll see when we look at the schedule, all of the train movements, passenger and freight, were based around meeting those stern wheelers at Rosebery and Nakusp. That was the way in and the way out of this railway, and so hence the trains met those schedules. Through this next section, I'm going to show you a number of images, and these are the images I want to model, and which give me the vision of what this might look like. So starting in Nakusp, Nakusp was pretty well where things started. Everything started here, and all the rail cars arrived. So the main station had the main line beside the agent's window, and then it had the wharf spur going down to the wharf, to the stern wheelers. So this one view here really summarizes what Nakusp is. There wasn't much else down at this point. The city was up on the hill above it. Also, the barge operations, which are just to the left of the stern wheeler there. This is a really old picture, but it's pretty close to early 1900s. It was an 8-car barge, wood, with the wood barge slip. So that whole barge operation is the other part of what Nakusp will be. Rosebery, again, had a stern wheeler slip with the wharf right there, and the wharf actually looked like it extended out into the water. The barge slip right there. and then the main line came in behind from Nakusp, and this is a great scene. So I really want to model this one scene with the hill, the main line coming around, barge slip, stern wheeler. The Alamo concentrator was the major building on the line and where a lot of ore cars are going. The picture on the right, you can see one of the ore cars unloading in the ore bin. That trestle on the front is actually the main line. So the main line from the left-hand picture came up Carpenter Creek, snaked up along the valley along the ring, crossed in front of the concentrator, and then up to Three Forks. So again, this will be a key view. Three Forks. Well, Three Forks was named Three Forks because there were three creeks, and they all converged here at Three Forks. So there was nothing else. It's a very narrow valley. You've got three creeks coming in, and you've got a rail line trying to go through. There was a freight house, there was a station, and there was an engine house. That was it. In the picture on the left, if you look up much higher on the hill, you can see the town was way up on the hill. So down in the valley here, it was creeks and just a bit of rail. Also, the stub switchback up to Sandon was here. So it was really a transfer point, and all trains had to go through here. Sandon had two creeks, so again, mines and concentrators. The mines, there were between 100 and 200 mines in this area, and the concentrators. On the picture on the right, you can see the entirety of the CP rail yard was on trestles. That was it. There's a few of those box cars, and that was the yard. Behind them, actually a little higher up, you'll see some rail cars. That's actually the Great Northern Castle in Sandon. So Sandon basically was creeks with the tracks on top of trestles. This was the end of the line, and again, some great images here that I'll represent. So, design criteria. What would keep my mind going through? So, visually in operation, I want to feel like 1906. I'd like to do role play for three engineers. They have to behave as if 1906. We've got the 1906 timetable. We've got rail barge ops at Nakusp and Rosebery, where the barge will actually move to the staging yard, so it won't be stationary. It'll be trying to move. We'll have stern wheeler ops at Nakusp and Rosebery. Again, the stern wheeler will have to come and go. Track layouts will be proto gradients, 2.5%, 3.5%, 4.5%. Lakes and creeks will be the focus throughout. Less than 10% will not be along a creek or a lake. 1906, May is spring with high water, so we'll represent high water at all the rivers. One scene per viewing arc. This is important to me. When I'm standing in one spot, I only want to see one scene. No wires, wiring, or automation. It is 1906. And we've got a couple finished rooms, 3 rooms that we can work with. However, we always have design constraints. So we only did get 3 rooms, so you take what you can get. I did occupy the electrical room for the engine house and charging, so that's a 4th room that's kind of quiet. We have 7 wall cut-throughs between the rooms. Those are important because there were no tunnels, so everything on a cut-through has to be scenic as a rock cut-through. Sandon will be at 55 inches, which is about as high as you can go for a 6-foot person to reach the switches and the equipment. Bottom shelf in the cusp is 34, so you can stand and operate. Minimum curb diameter is 8 feet, so Summit Lake is an 8-foot diameter rail around the lake. Minimum siding, it takes about 10 feet. You have 2 turnouts with 4 feet plus a 6-foot siding length. And 6 foot really only gets you about engine, a tender, a box car, and a caboose. Barge transfer slip has to be 6 foot. The barge and the transfer slip take up that much space at Nakusp and Rosebery. Stern wheeler wharfs at Nakusp and Rosebery, there need to be about at least 4 feet for the passenger train, 6 foot probably for the stern wheeler. Yard limits require a minimum of 10 feet for switching freight. 5 box cars gets you about 10 feet. The Three Forks switchback, that's a tough one. It's got to be 7 feet long because the ore train, the shade, the 4 cars, and the caboose have to do a switchback there. And that is the longest train there. We have turntables at Nakusp with Rosebery and Three Forks, and they are all 3 foot by 3 foot, and you have to reach them. So that takes a lot of real estate. And actually, we'll reuse all the engines, cars, rails, turnout, bridges, trestles from the outdoor layout. Okay, so if we look at the stations and flag stops now along the NNS, we start in Nakusp with the station on the Arrow Lakes. We go to Browse, which is a flag stop. Summit, which is on Summit Lake, is a flag stop. Hills, which is now down on Slocan Lake, is also a flag stop. And then we come to Rosebery, where we have a full station. From Rosebery, we continue along Slocan Lake to Denver Canyon, which is a flag stop. We go up Carpenter Creek to Alamo, another flag stop. At Three Forks, we have a station where we register. And then we continue along on up to Sandon, which is another station where we register. Okay, the image in front of us is the 3D rendering from the train software. When we bought the house, I inserted the dimensions of the basement into the train software, selected G-scale, and then started doing layouts to build the Nakusp and Slocan. After about 30 attempts of running the operation sessions, which were each about 2.5 hours, this is the layout I came up with. So let me walk you through it and we can show you where the trains will run. Starting in Nakusp, we have a station, we have a freight house, we have a fuel, we have water, we have an engine house, we have a turntable, we have the wharf, and we have the barge slip. From there, we head along and we start at 2.5% upward grade to Browse. From Browse, we go into the Roseberry Room, continuing our 2.5% grade all the way up to Summit. At Summit, we're at 46 inches, and we circle around the lake, and then we go back down the 2.5% grade in the Roseberry Room, and we end up at Hills when we're at 40 inches. From Hills, it's a level run over to Roseberry. In Roseberry, we have the barge slip, the stern wheeler wharf, station, and a freight house. From Roseberry, we now follow the Denver Canyon up a 3.5% grade. So we go around in the Summit Lake Room on the outside of the walls to Denver Canyon. We continue 3.5% all the way up to Alamo and Three Forks at 50 inches. Alamo is a concentrator. Three Forks has the station, a freight house, the turntable, water, and fuel. Three Forks also has the switch back to Sandon. From there, we go back to the Nakusp room. We follow the outside walls at a 4.5% grade all the way up to Sandon. In Sandon, we have the engine house and the turntable. We have a passenger station. We have a freight station. We have one concentrator, and we have two mines. And that is how the layout has been built. And that is what we will see in the video. Building the bench work. The top photo shows you the Nakusp room and what the bench work looks like. So what we did is I used 1x4 SPF to build an open framework. Every 4 feet there's a brace. On top of the open framework, I've actually added 1x2s, which you'll notice in the picture to go to a point. And my intent there is that there will be no fascia, so I will start the scenery from that point and go up to the track. Every 24 inches we have screws into the studs. Where we have more than 2 feet of width, I've added legs. Less than 2 feet, we're using 45-inch braces. So as we go around, we use a 1.5-inch ply that's 6 inches wide for the sub-road bed. The track is directly laid on this ply and it's held with brads. The track is 332 code and it has a 3/8-inch tie height. So between the code 332, the 3/8-inch ties, and the 1/2-inch ply, spaced with 12-inch spacers holding them, there is no give, even with the heaviest of engines. There's no wiring, no switch machines, no lights, so everything is dead rail. The trains all run with battery and remote radio control. Cut-throughs, which are 7, are a minimum of 12 inches wide and an average 14 inches high, which you can see in the lower picture. And this is so we can put scenery in them since there were no tunnels. And lastly, our tall trestles, there's 2 of them, are 40 inches high and they are built with a base on the floor. Okay, so that is how we have designed, built, and the operate is actually on the YouTube video, Nakusp and Slocan Railway G-Scale 1906 Build 4. It's a 15 minutes. It shows you a video of everything we've just talked about in this presentation, so I encourage you to watch it. I would like to thank the Arrow Lakes Historical Society for image use. They've been very, very supportive, and they give me great images that I can build towards. And also, I appreciate anybody subscribing to my channel, YouTube at DM3661. Thank you very much for watching.